At Contoso HVAC, we've been actually embracing the digital transformation and looking at how we can move from building HVAC and selling HVAC systems to actually selling a service around these HVAC systems, leveraging Azure IoT. One thing that, because we're going to be super successful, having more customers and more machine, we want to then leverage the same kind of infrastructure for IoT to optimize the actual operations in our factories to have less downtime, be more efficient in creating, in building these HVAC systems. It happens so that Azure IoT Suite has a pre-configured solutions for connected factory. And we do have an infrastructure that leverages OPC-UA on-site, on-premises, and these connected factory pre-configured solution will connect directly into my OPC-UA servers without any disruption or any intrusion or any breach in my security of my OPC-UA system to ingest the data from the machines in my factory. The dashboard that this connected factory solution offers actually includes KPIs that have been set implementing analytics on the data ingested. So where in the past I was able to only monitor raw data on-premise, what I can now do is do machine learning, do stream analytics on top of that data to determine KPIs, to determine efficiency of my process. I can also monitor alerts because I can set rules on these various types of data in order for me to see what's going on my various factories around the world if I have several of them. I'm looking right now at the list of alerts, and there's one that seems to be triggering something. So let me look in details about what's going on down there. So I can see here the various production lines, and there's a particular one that seems to have an issue with some of its parts. So if I dive into that configuration here, that alert here, I will see that very machine that seems to be the one with the problems. The assembly compressor station is malfunctioning. And in there, I can see the details. The pressure is the culprit. That's the one that is actually having issues. So here what I'm doing is I'm basically looking at the rules or the results, the outcome of the rules that I've been setting in order to determine that there's been a problem somewhere. And looking at the data, the historical data here on the last 24 hours, I see there's been drop in pressure. Just one click from the connected factory solution brings me into time series insights where I can then do the deep dive into the anomaly and what happened. So I can rewind and basically see what happened in the past and in a larger time scale. And you'll see that it's actually looking at something like 65,000 events. And in there, I can see exactly, the period when we had a drop of pressure. And this is where I want to dive, and I can do my insights, analytics of the root cause of the problem. So I want to go back real quick into my connected factory because I want to point at the fact that all the data we're seeing here has been collected, analyzed by the connected factory solution is actually directly coming from OPC-UA servers. We set up the proxy to enable that pre-configured solution in Azure to connect to these servers and gather the data. So it's very interesting and important to realize that we didn't have to be intrusive or to disrupt the actual OPC-UA infrastructure, but still we're now able to add a lot of value on top of that data, doing these rich analytics in the cloud and this dashboarding that allow me to then automate processes and so forth. So using the connected factory pre-configured solution, I'm now able to have a full-blown monitoring and I can do all my operation and detect alerts on my factory machines. And the thing though is that I'm still reactive. I'm receiving alerts and I'm actually implementing analytics on the data and so forth. But the problem is that I'm not proactive. I'm not preventing damages on my machines and so forth. What I want to do right now is bring that cloud intelligence at the edge. I want to be able to do these very rich data analytics that I can do today in the cloud. I want to do them on the edge, on devices. And Microsoft offers a solution called Microsoft Azure IoT Edge, which is exactly about that, bringing that intelligence of the cloud all the way down to the device. So let me show you how that looks like. I have this on-premise solution with that big machine controlled through a PLC, which is very typical industrial automation type of scenario. What I will need to do is add that box, which will be running Azure IoT Edge. It will be fully managed from Azure IoT Hub, and it will run what we call modules in there. The modules have a unique task or a set of tasks, but they're basically kind of an entity that actually has a role. And the first one that I will need is one called Modbus, and this one actually will be able to interact with the PLCs on my factory floor. So once again, we're not intrusive here. That edge device will interact with the PLC over the bus, which is the field bus of these very PLC. Then I can create new modules, other modules. Another one will be about filtering the data. Getting the data that is coming from Modbus and putting it in a format that then can be reused or can be interpreted by other algorithms or other modules. In the last box here, I will be running a stream analytics job. And the goodness with Azure IoT Edge is that I can bring full-blown Azure services like Azure Functions, Azure Stream Analytics, or machine learning even, all the way down onto IoT Edge. And I will show you in a minute how to actually do that. It's pretty straightforward. Stream Analytics job here has been configured in the cloud. I can deploy that on my edge device, and now right there, without having a back and forth to the cloud to do analytics on the data, I'm able to interact with that PLC and the machine. So something is about to happen, and I can determine that on average the data is actually going in a certain trend. I can determine with my algorithms that it's going to fail very soon, so I can stop the machine before it fails. This is the kind of scenario that actually I want to implement in my factory. So to show you how that works, here is the IoT Edge portal. Actually, this is the IoT Hub portal, and in there I can visualize the IoT Edge devices. They're part of that collection of devices that are connecting safely to Azure IoT Hub. The difference is that these ones, they have a particular configuration for defining which modules you want to run on the IoT Edge device. On the device itself, I'm running the Edge agent. That's the piece of software that Microsoft provides that will run on the device, that will connect safely to IoT Hub, retrieve a configuration, get the modules up from the cloud or down from the cloud, and run them locally, implementing the communication between the various modules. The Edge agent is actually in the full runtime of IoT Edge is based on Docker. And so I can see right now that I have one Docker container which is running, which is the Edge agent. Back to my dashboard, what I want to do is actually create what we call a deployment for that very device that is saying that it has an empty configuration here. And in this deployment, I've already preset a couple of modules. There's a sensor one, there's the Modbus module. So these have been created by some of my developers. The first one is actually simulating data from a sensor. The other one is actually the Modbus module, the one translating from Modbus to a format that my Stream Analytics job will be able to understand. And the last one is a Stream Analytics job that I've directly exported or created in the Azure portal for Stream Analytics. I created a job, defined that my inputs and outputs were the Edge Hub instance, and then from the modules configuration, from the deployment configuration, I can directly point to that Azure IoT Stream Analytics job and get it packaged as a Docker container and available for me to deploy. Once I have this collection of modules listed in my configuration for the deployment, I can then set up what we call the routes. The routes is what the Edge agent will use to have the various modules communicate with each other. So you define the outputs, the inputs. You say that the output number one of that first module is connected to the input number one of that other module, and you define that way the full pipeline of the data on your IoT Edge device. Another thing you will do when you define your deployment is which devices you have in the field that you want to run these very configuration. So on my example here, I can definitely have several edge devices connected to various machines on my factory, and I want them to run all the same configuration. So I can then select a condition or set a condition for which of these edge devices will be running that very configuration. Last but not least, I can review that deployment, and then I can submit it. What's going to happen is my Edge agent, which is running on the device, will ping the IoT Hub. What will happen next is that the Edge agent will download these modules and will run them locally in order to execute that new configuration. So if I actually look at the logs for the Edge agent, I should see things coming in. So now the deployment is created. What's going to happen is the device will actually ping IoT Hub and say, hey, what's my new configuration here? And it will actually pull down the various Docker containers. Oh, it did happen already. So if I look at now the various modules that are running on my device, I can see that now I have not only the agent, but I do also have the various modules that I configured, the temperature one, the Modbus one, and the Stream Analytics job. All of them have been pulled from the cloud by the Edge runtime, and then are running and they're communicating with each other and implementing that more rich solution that brings that cloud intelligence at the edge.